Hi guys, today we're going to be doing the first of a multi-part series where we're going to be talking about free stuff on Azure. So Azure has a number of different services, and the services generally cost money, but Microsoft has many of these services that are available for no cost to you. And you can use these services to run small applications on Azure. Now, I don't know that I would call any of these production level applications, but they're good for learning Azure. And it might be some things you can do with like projects or personal projects that you might want to run on Azure using some of these free services. So I'm going to be talking about a number of these over the next few videos, but today I'm going to be starting with the mean stack and how you can run this for free on Azure. There's actually a few ways you can do this, but I'm going to talk about one iteration of this today. And then I'll be doing another video that's kind of a follow-up one where I'm going to take the same application and redeploy it a different way, but it'll also be free to you as well. But this one is focused mostly on the mean stack and how you can use some of the platform as a service offerings on Azure to run this stack for absolutely no cost to you. And it runs fairly well for some general purpose applications that you might want to use for personal projects. So let's go over what the mean stack is in general, and then we'll look at how to implement this on Azure. So mean is just basically an acronym for MongoDB, Express.js, Angular, and Node.js. So if you're familiar with interior style architecture, this is basically where you have 3 tiers or maybe 4, depending on how you look at it. But you have a database tier, which is where you store all your data. Then you have some middleware, which is typically something running on a web server. And then you will have a front-end application that's written in HTML, JavaScript, and CSS. And that classic architectural pattern has been around for the better part of 20 years, and it's been implemented in a number of different ways. But mean is one of those implementations, and it just uses a select set of technologies that are open source for building these style of applications. So in this context, we have MongoDB for a database, we have Express.js and Node.js kind of as the middleware, and then Angular for the front end. And you put those together, you get the acronym mean. Now, if this was a different stack, you would have something like LAMP, which is Linux, Apache, MySQL, and PHP, or some other programming language. And in that case, you would use MySQL as the database. You would use Apache and PHP for the middleware. And then the front end would be an HTML, JavaScript app. It doesn't have a representation in the acronym. And of course, Linux for the operating system. And there are other implementations of this on Windows, for instance. It doesn't necessarily have an acronym, but you still have the same kind of thing that you would have with this, where you might have a SQL server, and then in the middle you would have an ASP.NET application running on Windows and IIS, and in the browser you would have some kind of application. It could be Angular, it could be React, it could be something entirely different, but you still have some kind of client running in the browser. But you end up with 3 tiers essentially in all of these. And mean is no different from those. It just uses a different select set of technologies. So let's go over these briefly. MongoDB is just basically a document database. So instead of storing rows in a table, you store documents like JSON documents in a database, and then you can use a SQL-like language to query those documents to pull them back to to whatever's calling it. In this case, probably a web service, and then serve that data back up through a web service or something like that. Express.js is just simply a web server. It's built into Node.js, and because of that, it integrates tightly with Node-based applications. It's not like a traditional web server like Nginx or Apache, which are general purpose, that can run other programming languages like PHP or some other language that you might be writing against that web server. Rather, this one is just integrated into the platform, so you can extend Express.js from its basic form to be very customized to your application. And then it's bundled with your application and deployed with your application rather than actually deploying your code to something like Nginx or Apache and the more traditional sense of web servers. In any case, it's just built in, it's integrated, so it's generally the one that folks use with the mean stack and most Node.js applications for that matter. And of course, Angular is a web front end development framework, and it provides you an MVC pattern for a browser-based application. The more classic examples written in JavaScript use AngularJS. The more modern manifestations use TypeScript, but still, AngularJS is a browser-based technology, and it allows you to have a framework for building applications, and it's highly extensible and has a lot of support, although it's kind of fallen out of favor for newer frameworks like React or similar frameworks that provide some of the similar things that Angular can do. Now, sometimes people will replace this with an R and make this the MERN stack and call it the Mongo Express React node stack, but you still get the same essence of what you're doing here, and you still have an in-tier application. And so you could still use the same approach for React if you wanted to do that, but I'm just using Angular for my example today. And to run this on Azure, you basically can use these services. So Cosmos DB has a Mongo API that you can use, and you can use it for free. So Cosmos DB offers up to 25 gigs storage and up to 1,000 RUs of throughput, which is fairly generous. I mean, it's not going to get you a high performance database, but for some applications, it's more than enough to run a given database. And then on App Services, Microsoft provides a free tier for running Node.js applications in the Linux context. And of course, Express and Node.js have been running in that same context because they're bundled together. And the App Service free tier gives you about an hour of total compute time per day. So if you don't exceed that, then your app will be able to field a request, and then it will shut down after a while. And as long as you don't exceed 1 hour of total compute time during a 24-hour period, your app will be available. So for low volume apps, that's probably not going to be a problem. And then, of course, there is the static web apps for the Angular components. And the static web apps are basically just a way to host static content. So anything that you could write that can produce static content, that's JavaScript, CSS, HTML, something that you would just basically download to a browser and run it in the browser, is something that you can put onto Azure Static Web Apps. And in this case, an Angular web app is something that you can deploy to Azure Static Web Apps. And so that is what we're going to be using to host our front end. So between these three right here, you have a full set of free services for running the mean stack. And so let's go ahead and take a look at how this is implemented on Azure, and then we will show you an example of this as we go through this. So I'm here in the Azure portal, and I have a resource group where I have a couple of things deployed to it already. I have an app service and an app service plan, and then I have a Cosmos DB account and a static web app. So all of these resources are free. So to start with the foundation, let's look at the Cosmos DB instance right here. So if I wanted to create one of these, you would basically just create a new instance of Cosmos DB. And so I'm not gonna be able to do it on this subscription because you only have one per subscription. But if you were to do this and you were to click on create a Cosmos DB account, you can create a Cosmos DB for MongoDB, and you can click apply the free tier discount, which will give you 1,000 RUs and 25 gigs of free storage and throughput on this particular database, which is, like I said, pretty decent enough for some smaller applications. And then once you create that, you'll now have a Cosmos DB account for MongoDB, and then you can use that to run something that uses MongoDB, which in my case is just a simple little app. And once you create that, you'll be ready to go there. Now, of course, you'll need somewhere to host your services, your backend application. And that's where I created a app service plan. So on an app service plan, if you just type in app services and you create this, and you create, or just type in web app rather, you can create a web app, and this one will allow you to, again, create a new web app, but you can choose the free tier right here, free F1. So the pricing tier is allows you to create, you can create a new one here. If I just chose ASDF, I don't know, I'm just going to create a random one here. And then you can choose the free tier. It gives you 60 CPU minutes a day, which is included. Now, that's going to be the CPU minutes per day. And so as long as you're not hammering on the CPU while your app is running, then that's probably going to be enough for a small application. That's assuming that it's going to be idle most of the time, and it's going to be on shared infrastructure for that matter too. But overall, if you're just running a small web app like what I'm doing, then you could just use this to host an API, and then the API will run quickly. And when the API runs quickly, then you're not going to be accruing a lot of total time. And that might work for maybe a personal blog or just a fun website that you're running for test purposes or personal type projects. So again, very easy to use, and you get the full app service experience without having to pay for it. And so it's a good way to learn app services and get used to how it works and all that kind of thing. And once you have that done, it will create both an app service plan and an app service for you. So the app service just basically gives you the context to deploy your application. And the app service plan is the resources that you have behind your application. And so I'm running a Node.js application. That's the stack I chose because this is the mean stack. So I'm going to be running a Node.js app. And the Node.js app I chose for this would run on older versions, but Node.js 18 is fine for this particular application. Now let's look at the other resource, which is a static web app. Now the static web app, again, is free as well. So if you create this resource, if you type in static web app here, and let's see if they can get one right here, static web app, you can create this resource. And if you choose this one, you can choose free for hobbies and personal projects. And that's not going to have any kind of like good SLAs or what have you, but it's generally good enough to host like a personal blog or a small app that you might be working on, or any other kind of personal project that you might want to use. And it's pretty basic. It's just static hosting. So it's not going to give you the ability to create backend APIs in the static front end, but it does come with a small implementation of a function app. So you can have some lightweight APIs, although it's more limited than what you would be able to do with a full-blown function app. But that is enough to get you something definitely to host a front end and a little bit of lightweight backend if you wanted to use function apps, which we'll explore that in a future video. But for now, this is what you can do to run your front end application. So you review and create this, and then you can deploy to this as well. So now that we have kind of all the Azure resources understood, now we have our 3-tier architecture we can deploy to this. Well, to do this, I'm just going to show you the app that I basically customized to run, and I adapted rather to run in this context. So basically, I just used a sample application that runs in mean stack, and it's got a front end that is written in Angular, and that's going on this right here. And it's got a database backend, which is going to be running on Cosmos. And then, of course, the service layer, which is a pretty lightweight service that's going to run on Node.js using Express. So here I have my folders that I'm going to be working with. I have my client, my server folder, and each one of these is a different folder that represents its respective part of the application. So the client is going into the static web app, and this is what's going to go into the app service right here. So if I go into this, this is a typical Angular app. It's got your source folder, and you would build this and then deploy it once it compiles the code. So the source contains the actual app, and it's got an index.js and a bunch of JavaScript, or rather TypeScript. And then what Angular does is it takes all of this stuff and then basically builds a few files from it, and then packages it in a way that you can deploy a bunch of compressed JavaScript, CSS, and HTML to a website. And it basically helps keep your website size down by allowing you to have a fairly complex application without a lot of overhead. So this is the app that I'm going to build right here. And this is pretty straightforward to build. Now, if I do a list on this, you can see that I have this folder right here, but this is the actual folder that contains the Angular app right here. So make this a little bigger so maybe it'll be easier to read. And to build this, you can use ng, which is the Angular runtime. So you can have it's got a built-in development server, but I can just run npm run build, and this will run ng build on this. That's because I use npm to install this. You can also run ng from a command line if you have it installed a different way. And so it just basically builds this, and then it drops it into this dist folder right here. And the dist folder contains basically an environment variable folder right here that contains credentials and other information about deploying this application up to the website that I'm going to be deploying to. And so that client folder right there has the code. So if I go into that client folder and do a dir on that, there's just the raw JavaScript, CSS, and HTML, and so on. So I'm going to go run the command that I want to use to deploy this, which uses the SWA command line right here. And this is something you can install from the npm installer as well. It's just the static web app CLI, and you can use deploy and then tell it what folder you're going to deploy from, and then what environment you're going to deploy to. Because App Services, or Static Web Apps rather, supports different environments, one for like a staging environment and one for a production environment if you wanted to see how your app might perform before you push it to production. And so this will deploy it to the production app, and it allows you to deploy it from a box into a static web app. Now, in the past, this wasn't possible. You had to use something like GitHub to do all this, but you can deploy it directly from a box now and kind of bypass GitHub. But we'll look at Azure DevOps and GitHub Actions as free services, but mostly Azure DevOps because that's a free service on Azure. We'll do a video where we'll take this app and create pipelines and code repos to deploy to Azure. So I'm just going to use the CLI for now, and then I'm going to deploy this. And it's basically going to deploy this up to the free Mongo My App, which is the static web app, and it's just going to basically upload some resources to that app, to that particular slot. And once that's done, your app is installed, and then everything is able to go. Now, this does take a little bit of time to complete, depending on the size of your application. This one is not too big. It's about maybe 0.5 MB, which is fairly small for some apps, but this is a kind of a trivial app. So there's the URL that I could visit, but there's a few things I need to do before I hit that up. So let's go ahead and make sure that my app on my app services is running, and then we'll make sure that this is able to hit that as well. So let's go take a look at the other side of this, which is the server-side component. So to build my server-side components, I'm going to do this on a Linux box because I don't want to build this for Windows, because some of the Node modules for Node.js might be Linux specific. So you want to build it in the context where you're going to be running. Now, you can do this through a DevOps pipeline, I know, but I'm going to be doing it manually on a Linux box. You could do this through a shell. I'm just using the UI, and I'm remoted into my Linux box that's kind of over here behind my shoulder. And this is just the server side of what I basically deployed a minute ago. I built the front end, which is agnostic to the platform that you're running it on. This requires that I build it inside of a Linux context so that all the node modules will match, and then I can upload that to the website. Now, this is just the source folder. Again, it's just a TypeScript app that's written using TypeScript, which will work with Node.js as well, because it basically just compiles down to JavaScript. And this is the package.json, which is the package management file for all the stuff that's inside of the source here. And then, of course, node modules. Since I've already built this, I have a node modules folder. Now, you could build this on the server too. I wouldn't recommend doing that if you're using the free tier, because building Node.js applications using some of the command line interfaces on app services can take a long time, because it's not exactly the most performant thing in the free tier. The best thing to do is just build it locally and FTP it up, which I will show you how to do in a minute. And that, or you could use a web deploy, but I'm going to use an FTP because it works. And it can take a minute because the FTP's got to upload a bunch of files, but anyway, it does work and it gets the job done. So this is what I'm looking at. So to build this, again, I'm just using a mean stack here. Nothing fancy here. That's the compiled TypeScript there. I'm looking for this command line right here. And this will allow me to run npm build, which is just calling TSC, which is the TypeScript compiler, and then that basically builds this output right here, what I'm looking at right there, which is JavaScript. And I'm just going to close without saving. And then it writes it out to this dist folder right here. And this is all of the output from this as well. So the folder that I'm going to deploy, however, is this one right here, because this one has the node modules in it, as well as the package.json and a few other things. But it's going to reference this folder right here as part of the output. So this is where my executable is. This is where my entry point is, my server.js folder file rather. And so the launch is going to actually look at this file right here, which is where I have wired up inside of this right here as the start. So node dist.server.js. So that will start it, and everything should work once I deploy it. So once you've built it, then you can install the node modules, build the code, everything's compiled, and then you can use FTP to FTP this up to your site. And this just uses FTPS, which is FTP over SSL. And you can get the credentials from that from the Azure portal. I'll show you how you can get those on any app service. If you go over here to your deployment center and you click on FTP credentials, you can get the FTP endpoint, then you can get the username, and there's the password. And then you can put those into whatever FTP clients you want to use, in this case, FileZilla, in my case. And then you can connect to that endpoint and then just upload files. Everything in my root here, under my dist folder, rather my server folder right here, is going to go up into my folder right here. So this is basically just a mirror copy of what's in this folder right here. And so I just took everything here and clicked upload and put it into this folder right here. And that deploys the application using FTP. Now, with DevOps, of course, there's a whole different way you can do this, which I'm just deploying from a local context. You could also deploy this using a web deploy using the Azure CLI. So again, I'm not saying that you have to do it this way. This is just the way I chose to do it today to show you a different way of doing it. So there's a lot of different approaches for this. So all of these are just different approaches to getting your code up onto Azure App Services. I FTP'd it up there, and once it was up and running, I was ready to go. So now that that's ready to go, we can test to make sure that this works. So let's go back to the browser over here, and let's see if we can get an endpoint. So I have an app service right here, and this is my endpoint, and this is my endpoint. But before I do that, I do need to make sure that my database is configured. So if I come back over here to configuration, I have a couple things here that I'm interested in. One is this Atlas URI, which is the endpoint, the connection string essentially for my database, and the port this is going to start on. And so this is going to start on port 8080, and that's how the backend will start on port 8080. Then the app service uses 443 SSL offloads, and then does a forwarding back to a backend port where Express is running, and that's how it works in the backend. But to get the connection string for this, I can come over here to my Cosmos DB account, and you can go to connection strings and get it right here, or you can go down to the quick start guide. If you're using a different stack, there's a let's see, the quick start right here. It's fine. There it is, quick start, and it gives you some basic boilerplate code for different environments. You can do net.net, Node, which is what I'm running, the MongoDB shell, Java, Python, and others. So this is mine right here. I'm not using this connection format right here. I'm using a different one, but I am interested in this connection string. And that's the connection string I'm going to be using inside of my app right there. So take that and then put it into the app settings on my app right here, my app service, and then populate the app service variable right here, the app setting. And then that will show up in my app as an environment variable, and I can read it. And then my app then connect to my Cosmos DB account. And so let's just test this to make sure it works. So let's go ahead and launch this right here. And it doesn't have anything at the root. So let's do this right here. I got an empty array, which tells me that there's nothing in the database. So that means that this endpoint is working. And this is the endpoint for the application to hit. That is my static web app. So this basically is the service side that my front end application is going to be hitting. And so this will be what I would put into my application. I'd already configured it to work. So with this in mind, I should be able to see this application work on my static web app hitting this app service, which then will interact with my Cosmos DB instance behind the scenes. So let's test this to see if it works. Okay, I'm back here in the resource group. I'm going to come back down here into my static web app, and I'm going to launch this guy, and this is going to launch the apps. It's just an empty list of employees right now. So if I click add new, if I put in Blaze Stewart, position architect, I guess I'm a junior level developer, and I'm going to click add myself to that. And then let's go ahead and add Jeff Procise, and he is our chief learning officer, and he's obviously much senior. And then let's go ahead and add in John Thompson, and he is the CEO. Let's put in Chief Executive Officer, and he is obviously senior as well. And so you have a couple of different names there. Now, I can probably edit these, but let's go look at the Cosmos database and just see what that looks like, and see if I have some records in there. So this created a database. So if I click on Data Explorer, I can come over here and poke around inside of my Cosmos DB account, and waiting for that to pull up. And if I come over here and drill down into my documents, I should have 3 documents in here. Yep, there we go. And there is Blaze Architect, and there is Jeff Procyse, and there is John Thompson. And so you see you have different documents in there in this database. So this will again hold up to 25 gigabytes of data. And for a little app like this, of course, this is going to be more than enough to handle this. But the way that this is working is using all free resources on Azure, where I have an interior application running the mean stack. So again, very useful for exploring Azure and learning a couple of things about it. So this is just a quick tutorial on how to run mean stack on Azure using free stuff. But we'll look at other ways to deploy the same application in future videos. We're going to be looking at how you can deploy this using some Azure DevOps pipelines, maybe some containers, and maybe even throw in some other interesting ways that you can run other things on Azure. So for now, let's just stick it with this, and look forward to seeing you on